Okay, so we're going to look at the practice problems on page 308, and we're going to start with number 18. And number 18 actually refers back to the example that we did before I assigned these or suggested these. So 18 says, determine the speed of the roller coaster car in the sample problem at point C. So we already did point A to B, and now it's at point C. And it says, which is 8 meters above the ground. So this distance here is 8 meters. And another 400 joules of heat energy are dissipated between B and C. So in other words, another 400 joules are the energy lost between B and C. Okay? And it wants to know, determine the speed. So we want the speed at C. So again, you're going to use energy, 1/2 mv initial squared plus mgh initial plus 1/2 kx initial squared is equal to 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. Okay, I would probably pick my initial up here at A because it's what I knew, but you could pick it at B as well. It really makes absolutely no difference. No matter which point you pick it at, you're going to have a speed. It's going to have a height, not going to have a spring. And at point C, going to have a speed, going to have a height, not going to have a spring, and there's going to be E lost. If you pick it at A, then the initial height will be 15, and the E lost will be the 3,400 plus the 400, so 3,800 joules. If you pick it at B, the initial height and speed will be different. It'll be the 6 plus the speed you found. That's why I'd go back to A, because we were given the speed at A. So I think I'd pick it at A. All right, and what am I trying to solve for? I'm trying to solve for the VF. So take your other two terms over. So 1/2 mv initial squared plus mgh initial minus mgh final minus E lost is equal to 1/2 mv final squared. Again, I would multiply everything by 2 and divide by m. So multiplying by 2, we'd have mv initial squared plus 2mgh initial minus 2mgh final minus 2E lost, and then divide by m. And remember, you can't cancel the m's out here. Even though there's 3 on the top, there's none in this E lost, and so you can't cancel it out. All right, so now we're going to fill our numbers in. M was, I forget, 200 kilograms. The speed up there was 4 meters per second squared plus 2 times 200 kilograms, 9.81 meters per second squared, and the height there is 15 meters, minus 2 times 200 kilograms, 9.81 meters per second squared, and the height at point C is 8 meters, minus 2 times the E lost. So for the E lost, I have to add my 2 E losses together, 3,800 joules. And then this whole thing gets divided by 200 kilograms. Okay, so be careful putting this in your calculator. Remembering to square that 4 and the minuses and the pluses. And you should get, before you take the square root, 115.34 meters per second. And then take the square root and get 10.74 meters per second. Okay? So that's number 18. Number 19 is similar. Diagram is different, but same idea. So this time you have a slope like this. Okay, and it's telling us our height here is 12 meters. And then there's a point X somewhere here. The height is 3 meters. Definitely not drawn to scale. And then Y is down here, right on the ground. And the initial speed up here is 8 meters per second. And so number 19 says, a sled at the top of a snowy hill is moving forward 8 meters per second. Height of the hill is 12 meters. Total mass of the sled and rider is 70 kilograms. And it wants to know, determine the speed at X, which is 3 meters above the ground, if the sled does 1.22 times 10 to the third joules of work. So there's 1.22 times 10 to the third joules of work done by friction on the snow on the way down. In other words, this is your E lost. And it wants to know what's the speed here. Okay, so it's going to be very similar again to what we just did. It's going to be 1/2 mv initial squared, mgh initial, 1/2 kx initial squared equals 1/2 mv final squared, mgh final plus 1/2 kx final squared plus E lost. So at the top, there is a speed, there is a height, there is no spring. At X, there is a speed, there is a height, there is no spring, there's E lost. And again, we're looking for VF. So once again, I would take my, I would take my other two terms over, I would multiply everything by 2, divide by M. So it'll be V initial squared plus 2mgh initial minus 2mgh final minus 2E lost. Okay, so I skipped steps there, but just because they were exactly the same steps as the one above, divide by M. Fill in your numbers. The M this time is 70 kilograms. The speed at the top, 8 meters per second squared, plus 2 times 70 kilograms, 9.81 meters per second squared, and the height initially 12 meters, minus 2 times 70 kilograms, 9.81 meters per second squared, times the height 3 meters, minus 2 times E loss, so 1,220, because it took up less space than the scientific notation, divided by 70 kilograms. Again, you'll get a VF squared. Again, you'll have to take the square root. VF squared ends up being 205.7229 meters squared per second squared. Take the square root and get 14.343 meters per second. Okay? All right, that was 19. Good news, number 20 is with the same diagram. Number 20 says, what's this, if the sled in the previous question reaches the base of the hill with the speed of 15.6 meters per second, how much work was done? So now down here, they're giving us a V final of 15.6 meters per second. We know the H final is 0, and they want to know what's the E lost in this section. Okay? Again, I'd probably use the top point because we know its speed. You just found the speed at X, but you could have screwed it up. So it's always a good idea to go back to this position where you know both the speed and the height. When we do that, though, we'll just have to be careful about our E lost, okay? The time's going to run out here, so I'll have just enough time to write down our big equation before we start the next video. 1/2 kx